All right, welcome back. Algebra 1. We are in section 5 today. You're not mishearing that. We are actually skipping section 4. Okay, so make sure that you pay attention right here. We are skipping 10.4, moving directly into 10.5. Okay, so we are going to be using square roots to solve quadratics. So this is a nice break from all that graphing that we've been doing in the previous sections. Getting into section 5, this gets us back into just using algebraic methods, which is just a fancy word for we're actually going to calculate to solve these quadratics rather than using graphs and having to figure out the points of intercept for the x-axis and all that stuff like that. So my honest opinion, this is a lot nicer. This is more on pace with what you guys would probably prefer to do rather than graph. So let's jump into it. All right, so first note here, we're going to zoom in. All right, so when you have a quadratic, you know that it makes this shape right here, the parabola, okay? And it's going to be an upward smiley face parabola here when you have a positive coefficient in front of x squared, okay? And then if you look further, and we are dealing with a positive value, and then that is just next to the x squared. So we're saying that x squared equals a positive value, then that is actually going to give you two solutions. And if you were to graph this, the reason why they're even showing you a graph is because you would cross two different points on the graph, okay? But the connection between those 2 points is that essentially they are the same number. It's just the positive and negative version of that, okay? So for example, if you had x squared equals 25, okay, so if you had that, then you would take the square root of both sides, just like this, and you would get actually two answers. You would get positive 5, and you would get negative 5. So we could write that as plus or minus 5. That's how you're getting two answers, okay? So I want to make sure that you understand you're not going to get positive 5 and negative 4, something like that. They have to be the same number. It's just the positive and negative version of that. All right, if you get x squared equals 0, all right, so that's where this is equal to 0, then you're only going to have one solution. That one solution is at x equals 0. That is because the square root of 0 equals 0. There's no positive and negative version of 0. It's just 0. All right, and then the last piece is what if you have a negative value? All right, so that's why I'm writing all these little parts over here. If d is a negative number, so for example, if we were to say x squared equals negative 9, all right, x squared equals negative 9. Yeah, the square root of 9 is nice. It's the number 3. But negative 9 is not possible. And you can never take the square root of a negative because when you square a number, it's always positive. Okay? So the square root of 9, yeah, that equals plus or minus 3. But the square root of negative 9 equals no solution because you can't take a negative and square it and somehow keep it as a negative. All right, so that's what this whole chart up here is describing. Now we'll zoom back out, and I want to make sure that you guys write what I have highlighted in this next line here. So when you're solving a quadratic, usually your first step is you're trying to isolate that variable. And how do you do that in the first step? You tend to start by adding or subtracting, okay? Then If you still have another step left, that usually tends to be division. And then the final step right there is taking the square root. Okay, so I'm going to zoom in here, and there's actually 3 example problems that are all worked out. They're color coordinated here by what I've highlighted. So what I want you to do is copy all 3 examples down, but copy them together by how I color coordinated them. This one works out great. This is all perfectly worked out together. But then I want you to put this and connect it with these 3 steps here. And then this one connected with these steps right there. Okay, so I want you to copy all 3 of those example problems down, and then I'm going to walk you through each kind of quickly right now. So this first one, 2x squared equals 8. You'll notice there's no need to do a plus or minus because we don't have that. So we immediately move into that step 2, which is let's look to see if division is required. And it is. We have to get rid of that 2. So that's how they do this. They divide both sides by 2. That's how the 8 is dropping down to become a 4, because they did 8 divided by 2, and that 2 crossed out. That's why over here the x squared is now by itself. Then how do you get rid of a squared? You have to take the square root of both sides. So that is what we're doing right here in this step. And then the square root of 4 is a positive or negative 2. So that's why we say plus or minus 2. Now let's take a look at the second example problem, letter B here. You'll notice we do have a plus and a minus, a subtraction sign. So we're going to have to add 18 to both sides. That will cross this and this out. That's what gets us down to this m squared is just 0. Now this is one of those where, what's the square root of 0? Simply 0. There's no plus or minus 0. It's just 0. All right, and let's take a look at the final example problem here with letter C. So you'll notice we have to subtract 12 from both sides. When we subtract 12 here, that crosses out. That's great. But then 5 minus 12, you should probably be able, even in your head, to figure out, well, that's going to be a negative. And that's what we're looking at here with b squared equals negative 7. Negatives are no good when it comes to that square root. So that's why right here, negative real numbers don't have real square roots. That's why the answer is no solution. Okay? All right, so we'll zoom out, look at one more example problem here. If you have a fraction, it is possible to take the square root of a fraction if both parts of the fraction are actually perfect roots. So what we're doing here is we're dividing both sides by 4. That crosses that 4 out, but you're left with this 9 over 4 piece. And that is where the z squared equals 9 over 4. It's possible to take the square root of 9 over 4 because what you will actually do is treat it like this. The square root of 9 over the square root of 4, which is 3 over 2. That's how they're getting down to that plus or minus 3 over 2. All right, so make sure if there's any piece in this video that you need to rewind, do so. Pause it, do so. Copy all the info down. That way you have it. All right, so let's do our own example problems here. We'll do 4 problems and then call it a day. Okay, so first step here, we have a 4x squared minus 100 equals 0. So we're going to have to do a little bit of everything. We're going to have to add first. Add 100 first to both sides. That crosses out, leaving us now with 4x squared equals a positive 100. Now we need to get rid of that 4. We're getting closer to isolating x. All right, so divide both sides by 4. They cross out here. 100 divided by 4 works out nicely. We get x squared equals 25. And this works out perfectly because 25 is a perfect root. Also, 25 is a positive number here, so we can take the square root. Square root will cross out with the squared, and the square root of 25 x equals plus or minus 5. Make sure that you remember to put in that plus or minus sign right there. All right, so that's number 1. Example problem number 2. We don't have any plus or minusing to do. So let's immediately move into step 2, which is let's divide to isolate that x squared. Divide both sides by 25. All right, that crosses out here, leaving us with x squared equals 16 over 25. Do not reduce, because if you look closely here, 16 and 25, what's special about them? They're both perfect roots. So that means we can take the square root of both sides and it will work out nicely. The radical will cross out with the square, leaving just x. Then what I would recommend is you think of this as square root 16 over square root 25, because that tends to just kind of help the brain compute a little bit better. So square root of 16, that's going to be 4. Square root of 25, that's going to be 5. But when we transfer this into our answer, let's not forget to write plus or minus, and then it's going to be a fraction, 4 over 5. And that is how that works out right there, okay? So yes, it's possible to take the square root of a fraction. You just need to look closely and see maybe this fraction actually is a perfect root. All right, so let's do the third example problem. Here we go. Okay, so you're going to see that we have to use addition or subtraction first, then some division. All right, so let's subtract 64 from both sides. That's step 1. To cross that out, 49x squared equals now a negative 64. Okay, then what we're going to have to do is some division. We got to get rid of that 49. So we have to divide both sides by 49. That crosses out. And there's our 49 right there. So here's what we're left with. X squared equals negative 64 over 49. Now, if you look closely, yes, 64, 49, yeah, those are perfect roots. They work out. But one thing you really have to zoom in on is that negative sign right there. That negative sign means that this is a negative fraction. And if you try to take the square root of a negative, it does not compute. It does not work. Therefore, we actually are looking at our first example problem that gives us a no solution as our answer. All right, because a negative does not work with square roots. Okay, all right, so let's do our last example problem. Here we go. All the steps are going to be in this one here. We are going to add 7, okay? So that's going to give us the ability to cross that out. And then you have 2x squared equals 2 plus 7, giving us 9. All right, and now we have to get rid of that 2. All right, we have to get rid of that 2. So we got to divide both sides by 2. Divide both sides by 2. That crosses out, that crosses out. So now what we're looking at is x squared equals 9 over 2. Now, if you look closely here, only one of these numbers is actually a perfect root, 9. The square root of 9 works out nicely. Square root of 2 does not work out nicely. So we need to proceed a little bit further in this so I can show you how you simplify. We will still take the square root, but what I'm going to do is I'm going to write this already as individual square roots, which is totally fine. So the square root crosses out with the square. Let's get a little bit more space over here. So what we have now is x equals square root of 9 over square root of 2. This can further simplify. Square root of 9 is 3. That's great. But you cannot leave a square root in the denominator. Okay, this is review of a couple chapters ago. So you got to go back and remember and think. You cannot leave a radical in the denominator. We have to go one step further. How do we get rid of that radical in the denominator? You have to multiply both the top and bottom by that square root, radical 2. And now think about those rules. Radical 2 multiplied by radical 2, this will equal 2. But now in your numerator, you have 3 radical 2. And this is what x is going to equal as your final answer. Okay, so we had to go a few more steps to get the answer here, for example, problem number 4. All right, so let's zoom out. There we go. There's all 4 example problems right there for you, worked out. Take a look at it. Bring your questions to class. Take diligent notes through these videos. I'll see you guys in the next one.